Express this in the form here. Use the result from part A1 to show that this equation has no real solutions. A curve has this equation. Find the coordinates of the vertex of the curve. Sketch the curve, indicating the value of y, where the curve crosses the y-axis. Describe the geometrical transformation that maps the curve with this equation onto the curve with equation y equals x squared. So there's the question then. So here's, I've written it out in summary form here. So let's have a look at A part 1 then. Here, x squared minus 6x plus 11 is equal to, half of minus 6 is minus 3. So if we put x minus 3 squared, that will enable us to obtain the x squared when we expand the bracket. Minus 3 will give us the minus 6x plus 9. We have 11, so we need 2 more on the 9 to get to the 11. So that's that done. And p here we can see p is equal to 3. Q is equal to 2, because it was minus p, wasn't it? So 3 is equal to p, and q is equal to 2. Okay, good. Use this to show that this has no real solutions. So part 2, x minus 3 squared then, plus 2 equals 0, implies that x minus 3 squared equals minus 2, which is not possible. Since we're squaring this, and this would be positive and this is negative, this would be greater than or equal to 0. This is definitely less than 0. So it's not possible. So it can't happen. So no real solutions. Solutions. Okay. Y equals this, then find the vertex as coordinates. Right, and sketch the curve. So here, y is equal to x minus 3 squared plus 2. I'm just going to do a tiny sketch of the curve, I think. So I'll draw it here, and we do sketch it here, like so. So this is for the sketch, and then we can also get the vertex at the same time. So the vertex would be, when x equals 3, y is 2, x is 3, y is 2, 3 and 2. So there's that point there. So that would be the lowest point in this curve, and then it would just, I've got a digital pencil, I'll draw a U-shaped curve, and it goes back up like so, sharply. So I've not really drawn that very well at all. So I'm going to do that again. Oops. Oh, managed to move the ruler here. Oops. There we are. So, yeah, let's just undo that then. And I'll do it a bit steeper. I'm going to pull this point down as well. If I can select the right tool. Here we go. So I'm going to pull that down, because I want to draw the curve a bit more steeply. Let's just quickly draw it then. So it's going to go down to here, and then back up to here. Okay, when x is 0, we get 9, plus 2 is 11. So this coordinate here, which we needed to mark off on the sketch, is 11. So that would be the coordinate, yeah? So the coordinate here, if we were writing it as a coordinate, it would be 0, 11. So, okay. So basically, the vertex would be at 3 and 2. Find the vertex as coordinates. So here, vertex is at 3 and 2. Okay, and then what do we do to make it go to the curve? Describe the geometrical transformation. So describe the geometrical transformation that maps this onto y equals x squared. So the curve y equals x squared is here. So something squared, so it's just going to shift that down to here, wouldn't it? That curve just simply needs to move. So if we shift that forward 3 and down 2, so basically we can see here that y, this is part part 3, do it in green, y minus 2 is equal to x minus 3 squared. So if we replace, so this could be compared with y equals x squared. So translation, isn't it? It's a translation. So we need to move it down. X-wise we need to move it along back 3, and we need to move it down 2. Back 3, down 2, and it will move to y equals x squared. That maps this onto that, yeah, so we would do that.